Okay, everybody, so let's recap what happened today. So we talked about a sequence, and a sequence just is a list of numbers or shapes or anything that has some order to it. Well, an example would be this one. I have a list of numbers, 5, 8, 11, 14, dot, 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 dot. So we're obviously adding 3 to each term. Therefore, we call it an arithmetic sequence. It is a sequence where you add or subtract the same thing as arithmetic. Okay? Example 2, we go 3, 6, 12, 24, 48. So what we're doing to get from one number to the next is we're just multiplying by 2 times by 2, and that makes it geometric. Example 3 doesn't have to be numbers. Here is a sequence: triangle, square, pentagon, hexagon, but the pattern is we're just adding one more side to it. You could say that might be your an arithmetic because you're adding one more, or it's just shapes. Okay. Domain, it does have domain. So we saw in our warm-up, the domain is always going to be these values. They're always going to be 1, 2, 3, because you've got your first term, your second term, your third term, your 14, whatever. So first term, second term, third term, fourth term. So the domain is always going to be the natural numbers or counting numbers. So it's always going to be 1, 2, 3, first term, second term, third term, fourth term, so forth and so on. And the range is just these values. So in this example, that's the range and that's the domain. It's just the values of each term. Okay? Domain and range. Domain are the x values, first term, second term, so it's always these numbers, and the range is going to be the values in each term. Okay. Now we also looked at our book, and our book went back to page 72, and in page 72 we answered some questions about our previous work. So we went back and looked at our family tree. I found our family tree was back here was the family tree, and we saw the family tree went 2, 4, 8, 16. So we can describe that as increasing. We begin at 2 and then we multiply by 2. We looked at collection of squares, which is right here. We wrote those back down, and that is obviously decreasing: 49, 36, 25, 16. And then the pattern is just decreasing by square numbers. Donna's daisies, well, that's kind of a weird one because it goes 3, 4, 2, 3, 4, 2. So it's increasing, then decreasing. Game Guru, if you go to there and look at Game Guru, you're going to start at 500. You're always going to add 50 points. So Game Guru is increasing. Polygon Party, triangle, square, pentagon, sides. So it's increasing. So start at 3 and add 1 to each side. And finally, the pizza contest, which we found here is the pizza contest. We're simply going to take half, 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 half. So we listed that one, and we said it's definitely decreasing. Okay. Then we compared them. What we noticed was the gamer and the guru. That's the gamer and the polygon party are both going to be what we call arithmetic. You're adding the same amount each time. Okay. We found the family tree and the pizza. Family tree and the pizza are both multiplying by some number, multiplying by 2, or in this case multiply by 1/2, so that makes it geometric. And then the third category is Donna's daisies and our squares are neither arithmetic nor geometric. They have their own pattern. Okay. What do all sequences have in common? Well, they all have a first term, and they're all functions. Every term has exactly one outcome. Okay, then we looked on page 73. Again, we talked about domain and range of a sequence. We've already talked about that. But in 5, it says that we start at 64, and we divide by 4, divide by 4, divide by 4, okay? Margaret says it ends at 1, and Jasmine says it keeps going. Well, if you keep dividing, it can keep going, it just gets smaller, smaller fractions. So it does, Jasmine's right, it can't go on forever. So then we talked about the difference between a finite sequence and an infinite sequence, okay? A finite sequence ends. I gave them an example of that. So, well, an example of that would be, I said, well, how about this? I've got like 1, 3, 5, 7, 9, or 1, 3, 5, 7, 9, dot, 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 dot. This one's finite. It stops. They look exactly the same. This one's finite because 11 is not part of this one. But 11 is part of this one. This one's infinite, finite. Sorry, it's so sloppy. Finite, finite. And this one's infinite, infinite. Okay? All right, and that's what we talked about. The homework. We also talked about this, that every term has only one outcome. That's what makes it a function. We looked at this sequence, which starts at 48. We took half, 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 and we can keep growing. And we create another one that is going to be increasing. So I did this one, added 2, added 2, added 2, added 2. Okay, and that's what we had for notes. Our homework was page 75 and page 76. Okay, that's all I have. If you want to watch this film, you can. And then we did a math thea. We did the math thea today on describing patterns in sequences. So that was our day today, and that summarizes it all up. Okay, that's all I got. Let's see if I can stop this recording.